For lesson 2.3's Ready, Set, Go, we are looking at intercepts and some other things as well. So let's go ahead and dive into this. For number 1 through 6, we need to be able to find the X-intercept and the Y-intercept. So first, it really comes down to what does that mean? The X-intercept is where the graph is going to cross the X-axis. The Y-intercept is where the graph is going to cross the Y-axis. And this is going to be helpful because it allows us to see what we're doing with the graph itself. So when something is crossing the X-axis, which is across here, the Y value is 0. So what we can do for number 1 is we can take the Y value to be 0 and find out what the X value is. So 3x plus 2 times 0 is 0 is 12, so 3x equals 12, x would equal 4. So we can plot that point 1, 2, 3, 4 units to the right on the x-axis. That would be considered our x-intercept. Our y-intercept is just the opposite of that. So when we are on the y-axis, the x value is 0. So 3 times 0 plus 2y equals 12. 3 times 0 is 0. So I would leave it as positive 2y equals 12. Y would equal 6. So 1, 2, 3, 4, 5, and 6. And the last piece of this is that one's not quite right. That one's looking better. Is creating a line that represents the equation. And I forgot to put in 0, 6 as my y-intercept. For number 3, same process, just different numbers. So I'll give myself some space on the side. It would be helpful for you to have space on the side as well, just to give yourself a spot to write things out. So for the x-intercept, we have 3x minus 7 times 0 equals 21. So minus negative 7 times 0 is 0. So 3x equals 21. X is equal to 7. So I know that my x-intercept is at 7, 0. And then my y-intercept, 3 times 0 is 0, so negative 7y equals 21. 21 divided by negative 7 is negative 3. So in this case, we would have our 2 points here. And finally, whoa, that's the wrong shape. That's the right shape. More or less, that's what we're looking for here. And again, 0, negative 3 is the y-intercept. Doing one more here, do number 5, and give myself some space. So for number 5, 2y equals 6x minus 18. I can do the same thing if I'm finding the x-intercept. 2 times 0 equals 6x minus 18. So 2 times 0 is 0. Then it's a matter of going back into the time machine and remembering how to solve equations. So we'll add 18 to both sides. 6x equals 18. Divide both sides by 6. And your x-intercept is going to be 3, 0. Similarly, for the y-intercept, 2y equals 6 times 0 minus 18. So 2y equals negative 18. Y would equal negative 9. So plotting that out, here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. And kaboom. 0, negative 9. And you have your x and y intercepts for each. All right, for number 7, 8, 9, and 10, you have yourself a nice little setup going. So first, it wants you to multiply. Then, circle the like terms, then simplify to a trinomial. Remember, a trinomial has 3 terms. So first things first, we need to multiply. So I'll take x times x is x squared, x times 5 is 5x, and then the other side, or the other part, is positive 5, distributing it in, so plus 5x and plus or positive 25. Wants me to circle my like terms, or put a box around them if you want to be fancy, and then simplify. Okay, that box that you're putting around it is going to be helpful very soon. So x squared plus 5x is 10x, and plus 25. This would be your answer that we're looking for. Okay, so in this, I'm looking at, can you identify those like terms? Plus 5x, plus 5x. Next one, number 9, gets pretty tricky because now it's 9x plus 1 all squared. Well, you can also write this as, and I'm going to encourage you to do this, is 9x plus 1 times 9x plus 1. Okay, that squared means that I'm multiplying it by itself in this situation. So we'll take that and go ahead and follow directions. So 9x times 9x is 81x squared. 9x times 1 is 9x. And then distribute the 1. Plus 9x and plus 1. Circle your like terms and then simplify. 81x squared plus 18x plus 1. And you're done. So the number 11 gets to be kind of tricky because write a rule for finding the coefficient b of the x term when multiplying and simplifying ax plus q squared. Well, we just did this for number 9. I hope that you're going to do this for number 10 as well, and if you see this for number 7 and 8, it also applies. Because ax plus q squared is really just ax plus q, that's a gross looking q, times ax plus q. And what you should be seeing is that you are taking 2 times a times q. Okay, I'm taking that a times q and I'm doubling it. If you look at number 7, if you look at number 9, oh heck, why not? If you look at number 10, so we can take a look at number 10 and see that it's 4x plus 11 times 4x plus 11, and we can distribute it in. 4x gives me 16x squared plus 44x, and then distribute this one in, plus 44x plus 121. You're going to put a box around your like terms, and then simplify. And this example might be a better one than the other two, just because it allows you to see what's happening. Take 4 times 11 and multiply it by 2. Well, you get 88. So that's what number 11 is really looking for you to do. Okay. The work that you've done for lesson 2.3 is preparing you for the set portion. Fill in the numbers that complete the square. So as we've worked on in the lesson, what you're doing is you're taking half of this and squaring it. So half of 10 is 5, 5 squared is 25. And writing the trinomial as the product of two factors means that we are going x plus 5 times x plus 5, or if you wanted to write the simplified version, which I would encourage you to start doing, it is x plus 5 all squared. Practice this a little bit more. Number 15, take half of that middle term, that b term, and square it. So half of 6 is 3, 3 squared is 9. Writing it as a factor of, or trinomial as the product of two factors, x plus 3 times x plus 3, or x plus 3 all squared. We'll practice one more, number 17. And once again, we're going to take half of that b term and square it. So half of 18 is 9, 9 squared is 81. X plus 9 times x plus 9, or x plus 9 squared. For the second part of this, find the b value that'll make the perfect square trinomial. So in the previous one, we were taking half and squaring it. Now we've got to figure out what we can do here to work the other way around. Okay? So the way before was taking b over 2 and squaring it to be able to get that c term. So we can plug and chug. We can try different numbers. Okay, for number 19, we can try 10. 10 squared, or half of 10 squared, is definitely not 121. Half of 16 squared is definitely not 121. Or what we can also do is this. We can take the square root of c and multiply it by 2. And that would give us our b value. So take the square root. Think about what two numbers multiply together to get 121. Well, I know that that's 11. I'll make that a little bit clearer for you. That's 11 times 2 gives me 22. And if I wanted to write this as a factor of two terms, x plus 11 squared is what I'm going after. Let's try it again. Number 21. Let's take the square root of 25, and if you do that on a calculator, it makes it a whole lot easier. It's 15. Multiply it by 2 is 30. So writing out the factors, you'd get x plus 15 all squared. Number 23. Take the square root of 169, you would end up getting 13 times 2 gives me 26. Writing out your factors, x plus 13 all squared. Hopefully you're seeing a pattern. Just like in Module 1, patterns are all around us. Well, in Module 2, they continue to be all around us. Number 25, take the square root of 9 over 4. So you're going to take the square root of the top, square root of the bottom, and you'll get, you guessed it, 3 over 2. But that's not all, because you're going to multiply by 2. So 6 over 3 would be that value there. Or it's not 6 over 3, whoops. 6 over 2 would be that value there. You could put it as 3 as well. I'm going to leave it unsimplified there just to see, but I also want to have it equal to 3. 6 divided by 2 should not be hard to simplify. So down below, x plus, what's that? Yep, 3 over 2 all squared. Just a little bit more fraction practice here. 49 over 4, take the square root of the top and the bottom. You should get 7 over 2. Then multiply it by 2. You would get 14 over 2, or 7. And your factored form would be x plus 7 over 2, all squared. For numbers 27 through 30, find the intercepts of the graph for each equation. Something that you can do is you can graph these. You can plug them into a graph and just kind of visualize what is happening there. Or if you already know, then that's great. You can go in and you can create yourself a little mini graph paper here. You can say that negative 4.5 is going to be all the way down here this whole time. So the Y-intercept will be at 0, negative 4.5. That should tell you everything you need to know. A Y is a Y-intercept at 0, negative 4.5. So without even graphing it, I've got this stuff in the middle here. This tells me that an X-intercept is at negative 8.2, 0. Graph it, see what happens. Okay. Hopefully this helps. Reach out if you have any questions at all.